Hi everyone, welcome to my first video of me going through questions for this series of more concepts. And today I'll be going through you guys about combustion of hydrocarbons. And to refresh your memories, hydrocarbons are compounds with carbon and hydrogens, such as your methane CH4 looks like that, or your C3H6, sorry, C2H6. And combustion basically means you're burning it or you're heating it. Yeah. So for those that have really read up further, that their notes or whatever it is, you would have come across this formula right here, which is CXHY, your hydrocarbon, being burned in oxygen gas to produce carbon dioxide gas, and your hydrogen, sorry, your water, your gas, your steam. And they will give you these coefficients. So x plus y over 4 for oxygen gas, x for carbon dioxide gas, and y over 2 for steam. And it's okay to memorize, but I don't think it's useful because you can forget it. So I think it's better to learn how to derive it instead. And it's just some math. So now I show you how I derive it. So first, actually, let me delete them. Okay, so based on what you have learned in O-level chemistry, you just want to balance. You have to balance your left hand side and your right hand side. Your number of atoms should add up. So left hand side atoms equal to right hand side atom. So now we first look at carbon. On your left hand side, you have CX. You have X number of carbon. And when you look at your right hand side, where can you find a carbon? It's here. There's no carbon in steam, in H2O. So how do you get CX here? You just simply have to multiply it by X. So then here you have CX, on your left you have CX. Okay, now when you look at your hydrogen, it is slightly more complicated because here you have Y in your subscript, your left hand side. So on your left you have your YH, have Y number of H, and then on your right you have a 2 here. So you have to be careful with these two, because what happens is that, let's say if you just put Y here, so the Y multiplied by the 2, you actually end up with 2Y number of hydrogen atoms instead of just Y. So to cancel out these two, you have to divide by 2. So the 1 over 2 multiplied by the 2, it will give you 1. So you end up back with Y hydrogens. So that's why here should be Y over 2. Let me just erase the arrows. Circle. Okay. Then now we have to go to oxygen, which is slightly more challenging because of the subscript 2 and 2 here, and then here we have a 1, nothing there. So on your left hand side you have an O2, and on your right hand side you have CO2. So now we have an X in front, so you can put X here first. So now these two are equal. Now what you have to do is balance this oxygen gas with your steam. So on your oxygen gas you have O2, but then in your water, in your steam, you only have O1. So how do you balance them? And if you were to just put plus Y over 2 here, you realize that it's not balanced, because there on your left hand side you will have Y oxygen because the 2 cancel out, and then you realize that on your right you actually have Y over 2O instead. So to tackle this issue, you have to do some math, and you realize that if you put 4 as your denominator here, you will get Y over 2, because Y over 4 when you multiply by 2 is Y over 2. So now on your left hand side you should get Y over 2 number of oxygen. So that's why you get this bracket here. And I know that this sounds very complicated and weird, but it's really math. It's like balancing algebra. Like let's say I have X equal to, like, let's say 1. How do you make both of them equal each other? You can plus 1 here and you can plus X here. Now they are equal to each other. Yeah, so it's this idea, and it might require some practice. So I hope this has helped you guys, and now we can move on to the first question. Okay, so this is how a typical question will look like. Let me just close this, then go this up a bit. Okay, so you have 10 cm cube of hydrocarbon. So this is your X, H, Y. Oh, why is it so thick? Okay, burn in excess of oxygen gas is your O2. After reaction, the volume gaseous mixture is going to be 80. When cooled to room temperature is important. Maybe I should use my highlighter instead. Upon passing the gaseous through aqueous volume decrease. What is the molecular formula of the unknown hydrocarbon? So now when you face this kind of question, the first thing you would like to do is just write down the formula first. State symbol to produce XCO2. And then you draw the I table. So I stand for initial. So and then C stand for change. And then E stand for N. So what by the end of the reaction? So since they give me volume, I will keep it in cm cube, cm cube, cm cube. So at the start I have 10 cm cube, and then I was burning 100 cm cube. So at the start you have 10 cm cube of hydrocarbon, 100 cm cube of oxygen gas, okay, and then you have none of these two, right? Then and then all of the hydrocarbon reacted, and then here's your stoichiometry, your mole concept. So you can imagine that there's a coefficient of 1 here, and to find how many moles of oxygen gas is uh, being removed, you have to take 1 and multiply by this. But in chemistry, your O-level chemistry, you have learned that under gaseous conditions, your volume is proportionate to the number of mole, right? So if 10 cm cube for hydrocarbon is burned, also it means that the coefficient for oxygen gas it should also be 10 multiplied by x plus y over 4. There should be this much volume of oxygen gas being removed, being reacted. And similarly, there should be 10x here produced. And oh, sorry, forgot the 10y over 2. So there should be 10y over 2 being also, there should be 10y over 2 water being produced, steam being produced. Then at the end, how much do you have? So 10 minus 10 have 0. Here is a bit ugly. There should have this much left, this much volume, not more, this much volume left. So because we're looking at gases, then here you should have 10x cm cube, then here you should have 5y cm cube. Okay, and then they tell you that the final volume is 80 cm cube when cooled to room temperature. The reason why I say it is important is because at room temperature, your steam become liquid, right? It condenses back to form water. So all this volume basically gone. So your 80 cm cube is just basically the excess oxygen and your carbon dioxide. Okay, so you can form this equation. Your 100 minus 10 plus y over 4 plus 10x is equal to 80. And then further on, they tell you that upon passing the gaseous mixture through aqueous potassium hydroxide, the volume decreased to 50 cm cube. So potassium hydroxide is basic. It react with acid, right? React with acid, which is your carbon dioxide gas. So it remove your carbon dioxide gas. So after passing through, your 10x should be gone. And since it decreased to 50 cm cube, not decreased by, So from here, you can conclude that this part here is actually 50. So now you can form the equation 50 cm cubed plus 10x equal to 80. Then you do the math and your x should be equal to 3. And then now you just have to sub your x into this equation. And then you should get your y equal to 8. And then now you just sub these two value back into your hydrocarbon. You should get C3H8. And this should be your final answer. So this is the molecular formula for the hydrocarbon. And in fact, this is a very typical classic example of how typical combustion involving gases will look like. And the only few variation that they can possibly have is, let me switch my highlighter, is instead of decrease to, they use decrease by. And then it's sometimes there may not be an excess, so sometimes it can be fully reacted. Yeah, so usually these are the only two variation you see. And another possible one is that it's not cooled to room temperature, so your H2O remains as gas, in the gaseous state. So you have to include the Y into your calculation. And this top chapter is very math heavy, as you can see from this table here to form all these equations, and you must know what volume you're looking at. But basically this is the gist of it. Yeah, just draw the ice table out and you should be good to go, yeah, for this type of question of combustion of hydrocarbons. So thank you very much for watching this, and I hope it has been useful for you. Yeah, so see you all in the next video.